All right, it's the first day of topic 3, and we're starting off with laws of exponents. All of these questions here are all about product rule. So we're going to do a different rule each day for laws of exponents. And the product rule just states that if you have two things that are multiplied with the same base, that's the important part. You got the base of x and the base of x, then all you have to do is add the exponents whenever it's multiplication. So keep the base the same, so x is still the base, and 5 plus 2 makes 7. Done. These are all the same base, so y stays the same. Same base, same base, same base. 3 plus 1 makes 4, plus 4 more makes 8. Same base here, so you got base of b, add the exponents, makes 0, and then anything to the 0 power is 1. Question number 4, this time we have what's called a coefficient. 7 times 5 makes 35, and then we have x. Okay, so we've got two bases now. We've got an x and a y. So I'm going to put the x and the y. X to the third times x to the first is x to the fourth. And y to the second times y to the ninth is y to the 11th. All you got to do is add the exponents. It's really just that easy. No coefficients this time, so there's no numbers to multiply in front by. We just got bases of a, base a, base a, base a. They all have the same base, so all we got to do is add up the exponents. 10 plus 2 makes 12. Plus negative 6 makes 6. Done. What rule of the exponents is being used? As I mentioned earlier, this is the product rule. That's what it's called, product rule. Product rule just states that if you have bases that are the same, then all you have to do is add the exponents and multiply the coefficients as you normally would. All right. So this lesson is about it's an introduction to exponents and seeing how exponents, even though they have different bases, can be the exact same thing. In this story, Sally has bacteria of 1 bacteria at 11 o'clock, and hers is doubling, if I'm not mistaken. I can re-look at this. I think hers is doubling every minute. Okay, the number of Sally's bacteria is by a factor of 4. Okay, so it's 4, not double. So that means she goes from 1 to 4 to 16 to 64. Now you would use your calculator, which I'm going to pull over here, and all you got to do is keep multiplying it by 4 for 1104. So at 1104, oops, there we go, pen. So keep multiplying 64 times 4, and that's going to give you 256. And then you're going to do the same thing and keep going all the way down. Now, I'm not going to do this right now because you've got a calculator. You can do it yourself. But Lupe's is starting at 1103, but his is on a heater. And we know bacteria grows faster. You should learn that in science. Bacteria grows faster when it has heat. And it's going to grow at a factor of 8. So it's going to go 1, 8, 64. 64 times 8 is 512. And what you're looking for is when are they going to be exactly the same. And if I'm not mistaken, I want to say it was like 1107, 4, 5, 6, 7. I want to say it was this row. I could be wrong. So check to see for yourself. All right, so laws of exponents. So it goes through the laws of exponents in this lesson. And as I just mentioned before, this is the product rule. Anything multiplied by itself with the same base. I'm sorry. Whenever you multiply things with the same base, all you have to do is add the exponents. So an example of that, I'll just do a couple examples trying to keep this short. 2 to the third times 2 to the second is 2 to the fifth. That's kind of like the warm-up what we did. All right, so then we have the power to a power rule. That means when you have one base with a power raised to another power, then you're going to multiply the powers. Now keep in mind that this is not the same thing as 4 to the 7 times 4 to the third. This is not the same thing because these are two with the same base. There's only one base in this question, so if I get rid of this, you notice there's only one base here. To the 4 to the 7 to the third is 4 to the 21st. That's called the power to a power rule. 13 is the base, times 2 times 4 makes 8. Done. It's really just that easy. Okay, laws of exponents, very simple. So this is division. This is called the quotient rule. Quotient means division. It means the answer you get from using division, to be more specific. Whenever you have the base being divided by something with the exact same base, all you got to do is subtract. I know you probably guessed that. It's the opposite of multiply. If you add when it's multiplied, then you're going to subtract when it's divided. So the answer here is 11 to the fifth. 7 minus 2 makes 5. This would be 8 to the first, or just 8, same thing. All right, then we have the negative rule. Negative rule means you got to flip it. So y to the negative second becomes 1 over y to the positive second. Once you flipped it, it's now become a positive exponent. This is 1 over n to the positive third. This one's 1 over 5 to the positive fourth. Now I could simplify that some more, but I'm just going to leave it as is. I could do 5 times 5 times 5 times 5, and that would simplify things a little bit more. Anything to the 0th power, this is the 0 exponent rule. Anything to the 0 power is 1. This is the easiest rule ever. All of these are all equal to 1. Well, the top is equal to 1 over 5 to the third, which would be equal to 5 to the negative third. This is equal to 1 over m to the 6th. Done. All right, so then let's get to the homework. The homework tonight, 2 to the x equals 2 to the 5th. Well, if we have bases that are the same, then we know the exponents must also be the same as well. You're probably not going to learn this in this lesson, but you definitely will in lesson 2 or 3. So if you have bases that are the same, then you know the exponents must also be the same. So if 2 to the x, what does x have to be? Well, it has to be 5, because this one's 2 to the 5th. 10 to the x is equal to 10 to the negative 9th, then we know x is negative 9. If 3 to the x is equal to 3 to the 4th, then x must be 4. See the pattern? It's very easy. It's just the same thing as whatever this is. All right, this one's easy as well. So if the bases are the same, cancel them out. X must be 5. Done. Bases are the same, cancel them out. 8 must be x. Done. This time the bases aren't the same, so this gets a little bit trickier. So I'm going to change the base. I want to make 32 have a base of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 2 to the 5th power is the same thing as 32. That's like saying 2 times 2 times 2 times 2 times 2, 5 times, is 32. So now we know x is 5 because the bases can be canceled. They're the same. Bases are already the same. X is negative 10. So easy. Bases are already the same. I know you freaked out when you saw this. You saw fractions. You freaked out. It's not. Look at this. I solved it in literally 2 seconds. X is negative 5. All right, this one. Do see fractions. Okay, don't freak out. 3 to the x power is equal to. Now, 1/27th, go to that negative exponent rule. Remember, you can flip it. So you could say 1 over 27 is the same as 27 to the negative first over 1. Okay, that's one way of looking at it. Or you can just remember that, well, 27 is 3 times 3 is 9 times 3 again is 27. So this is the same thing as 1 over 3 to the third, if you want to do it this way. And then flip it becomes 3 to the negative third. Okay, I'm just going to go straight to the 3 to the negative third. This and this are the exact same thing. And then we know if the bases are the same, then the exponents are also the same. X is negative 3. Done. Okay, great. There's the end of the first lesson. Let me know if you have any